When you want to write some Elixir code, starting a mix project is not a bad way to go. It provides structure for your tests, dependencies, and configuration. Typically, an Elixir application lives inside of a mix project. Application in Elixir refers to a module that is used to wrap the supervision tree. That module will provide callbacks for starting and stopping the application as a unit. The code inside of a mix project doesn't have to be part of an OTP application, but it will still be convenient to use Mix project for its structure. Mix is a tool that fetches dependencies, runs tasks, compiles project code, and knows how to run an application. It does quite a few different things. In this presentation, we're going to use Mix to create a project, go over project components, introduce the application module, and start building a real Elixir application where we'll apply GenServer and Supervisor concepts. Instead of basic structural examples, though, this project will be doing something a little more interesting. We're going to rely on GenServer and Supervisor modules. If you're not familiar with those, please check out the previous videos in this series that introduce those modules and go over their usage and syntax. For our project, we're going to start a package delivery company. We will need to deal with things like distribution and routing, which means we need to solve a pretty important problem in the delivery industry, and that is to figure out where everything is located. To calculate the distance and delivery routes, we're going to need some geolocation data. The dataset we're going to work with is going to be fairly simple. The three values we're going to use are the postal code, the latitude, and the longitude. So, the first requirement of our delivery company is to get geolocation data and build a reliable geolocation lookup service that will help route the packages to the closest distribution center and later on help set up an optimal delivery route. But before we could do all that, the first step is to start our project. To create a project, we're going to use Mix, which is a build tool that comes with Elixir. To start a new project, type mix new lhex delivery, and let's get into that directory and see what we got. This is what's inside the directory that was generated. All the code is going to be in lib, with the only thing here so far is the module that was created by default based on the name. The test directory is going to have tests using xunit, and the project file mix.exs is going to have everything Mix needs to know about the project, including dependencies, compilation, and how to run the app. One important note is that what we created is a Mix project. Note that we are using Mix project module here at the top. Project and application are related but not interchangeable terms. The application refers to the Elixir OTP application, meaning the code for the entire supervision tree. The project includes the application plus the dependencies, tests, and all the configuration details. Take a look at the two methods defined in this module. We have the project method and the application. Inside of the project method, we have the name of our application, the version of our project, the version of Elixir we'll be using, and a list of dependencies that's defined as a separate method here. Build embedded option is going to be true in production. What it means is that all the code that's necessary to run our application is going to be included in the compilation. In test and development, it's more convenient to link to some things that exist locally, rather than include them in the compilation every time. Start permanent option is also only going to be true in production. It means that when our supervision tree gets shut down, the virtual machine will crash, which won't be convenient in test and development environments. Inside of the application method, we have a list of applications that need to be started before our main application. We also need to designate a module that will wrap our main supervision tree, which we'll do at a later step. Before building our OTP application, let's get some geolocation data. We can get postal code geolocation data by heading to census.gov. Once there, click on Geography, select Maps and Data, find our geographic index files in the right column, and select the latest year. Once there, you'll find our postal code information on the bottom. When you download it, you'll get a 7-column tab delimited file, with the first column being our postal code, and the last two being the latitude and longitude. Let's place the census file inside of a data directory in our project. Now we need to write a module that will parse this data and load it in a format that we'd like. This will be a plain Elixir module namespace inside of the postal code directory. The first thing I'd like to do is to get a list of data rows by loading in our file, and then taking that file string and then splitting it by the newline character. At this point, it would be a good idea to verify that our data rows loaded in properly. The best way to do that is to write a test. This file is named after our module with the word test appended to it. Notice that the extension on this file is exs, meaning that it will always be run as a script without being compiled. We're going to alias our module, which defaults to whatever comes after the last dot, meaning that we can refer to it by the name data parser without the rest of the prefix. Our test is going to be incredibly simple. In fact, technically it's not even a test since we won't have any assertions to begin with. All we're going to do here is to call parse data method on our data parser module, grab the results, and just print out the very first element, just to be sure we don't get any errors and everything works as expected. Running mix test will run all our tests. So you can see here we get our tab delimited row, which is what we expect, and we also get a warning saying the variable header isn't used, which we're going to fix right now. We can ignore a header variable by starting with an underscore, meaning we don't intend to use it. Since we're dealing with a tab delimited file, the next step is to map over every row and split it by the tab character, giving us a list of columns. Once that's done, we can run the same test from before to confirm that our parser still works. It looks like it does. Since we won't need all values from our file, we can map over each row again, pattern match on all 7 columns, and just grab the data that we need. What we will end up with is another list of postal code, latitude, and longitude. When we run our test, we get a no match error, which is probably the most common error you'll see in Elixir. What it means in this case is that whatever we specified on the left side did not match whatever was on the right. Since we did not provide any exact values in our list, I suspect this is simply because we provided a wrong number of elements. Looking back at our code, we can see that we specified 8 elements instead of 7. When we run our test again, we still get a no match error. This time though, it's because we couldn't match a 1-element list that just consisted of an empty string. This is because our tab delimited file had an empty line at the very end. To fix this issue, we need to filter our rows to be sure that we're only working with the data that we expect. We'll change our map method to a filter method and add a case statement. Filter method will only hang on to the rows that match a pattern or a condition that we provide. In our case, all we care about is that the list has 7 elements in it. Everything else is going to be false. Having our data in the proper format, we can add the map method that we had before, and after that's done, we can run our test again. Our test passes with a few unused variable warnings from the filter method, which we'll need to fix. After that's done, we can move on to the next step. What we are going to do is transform each row from a 3-element list to a 2-element tuple, which we could then easily load into a map. We also need to clean up our latitude and longitude values by getting rid of all that extra space and converting them from a string to a proper floating point number. Once we do the same for longitude, we can take that result and load it into a 2-element tuple, with the first element being the postal code and the second element being another tuple of latitude and longitude. Let's run our test and see what we get. Looks like we got our 2-element tuple with the postal code as the first element and a latitude and longitude as the second. The only thing left to do now is to load our list into a map. I expect our test will still work, but now since we actually have the data in the proper format, we can write a proper test. At this point, we actually have proper geolocation data in the format that we want. To test it, I'm actually going to plug in a familiar postal code and expect to get a latitude and a longitude as my value. Here I'm also confirming that my value is going to be a 2-element tuple. In addition to that, I'm going to make sure that both latitude and longitude are proper floating point numbers. When we run our test, it passes, which is great. Looking back at our code, I feel like it's starting to be a little bit difficult to follow, especially if you haven't looked at it in a while. I would also like to see if there is a way to improve this test performance in any way. We can start doing some cleanup by replacing this fairly trivial iteration code with the ampersand anonymous function shortcut. It's always a good idea to run a test just to see if our improvement broke something. Moving on, we can take the code inside filter and move it into a separate private method. Doing that has an added benefit of naming the method, just so it becomes clear what the code is supposed to be doing. In this case, our data row method is going to check if our row is a data row, and the question mark at the end of the method implies that the return value is going to be a Boolean. So now we can just replace this code with our new method and see if it works. Looks like it does, so let's keep going. We can do a similar thing with our row parsing method here. Just start a new anonymous parse data columns method. Move all the code from our map method into here. Delete the code in the map and replace it with our new parse data columns method. And again, it's really important to keep an eye on our tests as we're doing this. Notice that the code for parsing latitude and longitude is identical. Even though it's trivial, it's still a good idea to move this into its own method just to avoid this kind of duplication. Let's check in on our tests and keep going. The last method we can abstract is the row format transformation method, where we actually load the data from a 3-element list into a 2-element tuple. With the same idea in mind, we can create a new method called formatRow, take all the contents from our map method above, and pretty much move everything down here. We also need to parse the latitude and longitude in the same way, and just replace the contents here with the formatRow method. When we run our test, we get a failure. Now you can see that the problem happened on line 32, and it looks like we have a missing parenthesis. So unfortunately, what we gained in line numbers, we lost in clarity. So what I intend to do now is to add a few comments explaining exactly what this method does, and move out the latitude and longitude function calls outside of the return value. So let's add our comments where we explain the method's intentions and give an example of what the return value is supposed to be. Next, let's move out the parse number function calls from outside of our return value into their own variables above. Then change the value in the return just to use the variable names. Hopefully now our test passes, and it does. One thing we can do in terms of our code performance is to change from greedy enum module into lazily evaluated stream module. This should make the processing much more efficient because each iteration will not have to wait for the previous one to finish before it gets started. I expect our tests will still pass and will be slightly faster. Well, looks like it's 0.3 seconds faster, or about 25% in this case. So after all that, we ended up with a pretty efficient geolocation parser method that's not too bad to look at. Next, we're going to write a GenServer module that's going to load and store this data so that we can access it dynamically. Here I'll be passing an empty map to the init method, which isn't necessary, but I find it helpful to specify what data type our GenServer state is going to hold. We can provide a name for our process, which we can then use as a reference. The benefit of that is that we don't have to worry about tracking the process ID, since we can always refer to it by its name. The drawback of naming a process is that we won't be able to run multiple processes of the same type. We'll call our data parser module from inside the init method. We'll add an alias for it so that we can refer to it without its prefix. The data parser module is going to be called each time we start or restart our postal code stored GenServer process. The init method has to respond with OK and the state that our GenServer process is going to hold. which is our geolocation data in this case, with the postal code as the key and latitude and longitude tuple as the value. The GenServer process will not start if there is some kind of an error during parsing. There is also a default timeout on the init method, which you'll have to keep in mind if you're working with a bigger dataset. So now that our data is going to be loaded in, we can write a lookup method to get geolocation data by the postal code. Notice that we don't have to explicitly pass in the process ID to this method since we can refer to it by its name. Now we're going to write a synchronous callback method that's going to get our geolocation data by the postal code. It needs to be synchronous because whoever is going to be calling this method is going to expect the latitude and the longitude as the reply. Remember that the GenServer callback responses must be in this format, with the second element being what our caller is going to receive, and the third element is going to be the new state of the GenServer process, which in this case just stays the same. We can try out this code right from the Elixir console. Type iex-s mix, which will load the code from the current directory and start the console. Next, we'll start our postal code store GenServer process. And notice that we'll get an error if we try to start it again because we can't have two processes with the same name. And when I pass in the familiar postal code to getGeolocation lookup method, I get back my latitude and longitude. It works, and I can quit the console with Control-C. Of course, it's still a good idea to write a test for this method, which we'll do right now. We'll call our test file stored_test at getGeolocationTest method and alias the module. Since we haven't wired up our application, we still have to explicitly call startLink on our module. After that, we can call getGeolocation method with a familiar postal code and expect back a floating point number for both latitude and longitude. Once that's done, we can run our test. Looks like they all pass, so that means we get to keep going. I would like to add a postal code supervisor module that's going to monitor all worker processes related to postal code and geolocation data. We'll put the supervisor file into the postal code directory inside lib. Inside the init method, we'll specify our children. So far, we just have one worker to monitor, which is the postal code store module. Next, we'll call the supervise method, pass in the children, and specify the strategy. We can try out our supervisor from the console. If everything works as expected, we won't have to explicitly start our GenServer store process since the supervisor would have done that for us. When we run it, that's going to fail, but that's because we were missing the word store from the module name. Once we add that back, everything works. We can quit the console with Control-C and keep going. We'll add an alias to the postal code store module so that it's a little bit easier to look at. Next, we're going to create the main or the top level supervisor that's going to start when our application starts up. This supervisor is going to live in the top level directory in lib and is going to monitor all other supervisors, including our postal code supervisor. Now I want to note that we could have had our store worker directly under the main supervisor here. I mostly wanted to demonstrate a supervision tree with some depth. Keeping the postal code workers under their own supervisor will allow us to keep any problems that might cause isolated, and it's also good for code organization once our application starts growing in size. Now we need to go back to the very first module that was generated by default and turn it into an application with a callback method that's going to start our main supervisor. And that's all we'll ask it to do. Once everything is wired up properly, we can expect all the GenServer processes under the main supervision tree to start up as well. Mix is going to call the start callback method by default. Going back to the console, we can expect to use postal code store getGeolocation method without having to start up anything explicitly. However, we get an error saying that our process isn't running, so what's happening? We can even confirm that our application is running by typing in application.start with our application name, and that should fail with an error saying it already started. What we need to do is go back to our mix file and specify the module that we want to use as our application. The module we'll provide here will be expected to use the Elixir Application module and will be responsible for starting the entire supervision tree. In this case, this is just a module that was generated by default that we then turned into an application. And now that everything is properly wired up, we can go back to the console again and run our postal code store get geolocation method without having to start up anything explicitly. We can now use this method throughout our application. That includes our tests, which means we no longer need to start it up explicitly here. We can take it out, run our test, and still expect everything to work. So what we have so far is our application that starts the main supervisor, that monitors our postal code supervisor, that in turn monitors our postal code store worker that contains all our geolocation data. In the next video, we're going to be adding the navigator module, which we'll use to calculate distances between postal codes, and we'll add the cache module, which we'll use to improve performance of our distance calculations. This video showed how to start an Elixir application, went over GenServer and Supervisor concepts we learned so far, and touched on some code refactoring, testing, and debugging. I hope you enjoyed it, and thank you for watching.